everyone, I'm Kristel and Celemin from the Pampanga State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105. This video is all about the summary of the chapter 7. So, the chapter 7 is all about the IP addressing. So, let's start. Addressing is a critical function of the network layer protocol. So, it means that the addressing is very important to the network layer protocol. So, addressing enables data communication between hosts regardless of whether the hosts are on the same network. So, we use the addressing for us to have communication to the other network. So, we use the IP address for us to communicate to the other devices or the router or the switch. So, next one is both Internet Protocol version 4 and Internet Protocol version 6 provide hierarchical addressing for packets that carry data. So, they are hierarchical. So, designing, implementing, and managing an effective IP addressing plan ensures that networks can operate effectively and efficiently. So, they make sure that it can operate effectively and efficiently. So, they can operate correctly. So, next is it's all about the IPv4 addresses or the Internet Protocol version 4. So, let's start with the version 4. So, binary is a numbering system that consists of 0 and 1 called bits. The bits are 0. If we are talking about the binary, so the only number that it has are 0 and 1. So, it's binary, it means 2, 0 and 1 only. So, in contrast, the decimal numbering system consists of 10 digits consisting of the numbers 0 to 9. So, if it is decimal, so it consists of 10 numbers, that is start from 0 to 9. So, binary is important for us to understand because the host servers and network devices use binary addressing. So, the host servers and network devices they use the binary. So, that's why we need to understand, or we need to know the binary. So, each address consists of a string of 32 bits divided into 4 sections called the octets. So, 32 divided into 4, so that's 8. So, that's why it is called octets. Octets means or octagon or 8. So, octet. Each octet contains 8 bits or 1 byte separate with a dot. Next one is the positional notation. So, learning to convert binary to decimal requires an understanding of the positional notation. So, positional notation means that a digit represents different values depending on the position the digits occupies in the sequence of numbers. You already know the most common number system, the decimal base 10 notation system. So, the position notation is the 1, 2, 4, 8, 16, 32, 64, 128, and so on and so forth. So, they are the position. So, for us to easily to convert the binary numbers into decimal, so we will just add the numbers in the position that has a 1 in the binary. So, next one is binary to decimal conversion. So I will teach you on how to convert the binary number to decimal. Then, to convert a binary IPv4 address to its data divided IPv4 into 4 8-bit octet, then apply the binary positional value to the first octet binary number. So, if we will convert the binary in IPv4, so we will first divide it into 8-bit. So 8-bit octet. So as I said a while ago, so we have the positional 1, 2, 4, 8, 16, 32, 64, 128, then and so on and so forth. Then we will add the numbers that has 1 in the positional numbers. Like for example, if we are given that the bit that 1 1, then 0 0 0 0, then it means that 128 and the 64 only has 1. So we will add the 128 and 64. So 128 plus 64 is equals to 192. So that is the if we convert that binary into decimal, the answer is 192. So next is the decimal to binary conversion. So a while ago we convert the binary into a decimal. Now we will convert the decimal to binary. So what we will do is we have the decimal number. So we can write the 1, 2, 4, 8, 16, 32, 64, 128. Then we will put 1 on the position that will have a sum of the given decimal. For example, the given for this is 7. So we will put 1 in 1, then 1 in 2, and 4 in 1. So since that 4 plus 2 plus 1 is equals to 7, we can conclude that all the remaining position will be 0 because we got the decimal number. Next one is network and host portion. So understanding binary notation is important when determining if two hosts are in the same network. So for us to understand if the two hosts are in the same position, then recall that an IPv4 address is a hierarchical address that is made up of network portion and the host portion. So the subnet mask. The subnet mask is used to identify the network or the host portion of the IPv4. So the default subnet mask that we are using in the packet tracer is the 255.255.255.0. So again, that is used to identify the network or the host portion of the IPv4 address. The logical end. So a logical AND is one of the three basic binary operations used in the digital logic. The other two are OR and NOT. While all three of used are data networks only and is determining the network, therefore our discussion. We can say that 1 is true, then 0 is false. So if 1 and 1 is equals to 1, so or true. If the true and true is true, then if it is 0 or false and 1 is true, so it is 0. if it is 0 and 0, it will become 0. Then 1 or true and 0 is false is equals to 0 or false. So to say that it is if it is has 0 or false, it will be automatically be 0 or false. The prefix length. So expressing network addresses and host addresses with the dotted decimal subnet mask address can become cumbersome. So fortunately, there's an alternate shorthand method of identifying a subnet mask called the prefix length. So the example of the prefix length is the /8, /16, /24, /25, /26, /27, /28, /29, and /30. Network, host, and broadcast addresses. So, network addresses and subnet masks refer to a network. All hosts within the network share the same network addresses. So, the host portion is all 0. So, network. So, addresses and subnet masks refer to a network. So, if it is network, so it is address and subnet mask. Then, if it is a host, all hosts within the network share the same network address. So, then the host portion is all 0. So these are the differences of them. So static IPv4 address assignment to a host. Devices can be assigned an IP address either statically or dynamically. So statically, static means it cannot be changed, and dynamically it can change. The IPv4 communication. A host successfully connected to a network can communicate with other devices in one of 3 ways. So, if the host is connected to the other network or other devices, it can communicate properly. So, there are 3 ways on how to communicate with the other devices. So, the first one is the unicast. So, the process of sending a packet from one host to an individual host. So, if it is unicast, it is from the one host to the individual host. It means 1 to 1. So, one host into individual host. Then, the next one is the broadcast. The process of sending a packet from one host to all hosts in the... So, it is from one host to all hosts. So, a while ago, it is from one host to only one host. Then, now it is one host to all remaining hosts. Then, the multicast is the process of sending a packet from one host to a selected group of hosts. So, if the multicast is from the one host to selected group only. So let's differentiate that 3. So the unicast is 1 to 1. So we can say that it is one network into one host, or one host to one host. Then the broadcast is from one host to all hosts. Then the broadcast is, or the multicast rather, is from one host to a selected group only. So if the broadcast is for all, then the multicast is only a selected group. So So, public and private IPv4 addresses. Public IPv4 addresses, which are globally routed between ISP routers. However, not all IPv4 can be used on the internet. There are blocks of the addresses called private addresses that are used by the most organizations to assign IPv4 to internal hosts. So, specifically, the private addresses blocks are 10.0.0.0/8. /8 is the prefix length, or the 10.0.0.0.255.255.255. So, and then 172.16.0.0/12, or the 172.16.0.0 to 172.31.255.255. Then the 192.168.0.0/16, or the 192.168.0.0 to 192.168.255.255. So they are the private addresses blocks. So, special user IPv4 addresses. So, the loopback addresses, or the 127.0.0.0/8, or the 127.0.0.1 to 127.255.255.254. So, more commonly identified as the 127.0.0.1. Then the link local addresses, the testnet addresses. So next is classless addressing. These are the summary of the classful addressing. Class A is 50%. Total networks is 128. Then the total host, or the net, is 16,777,214. Then for class B, it has a 25%. Total networks are 16,384, and the total host or net is 65,532. And the class C, or the 12.5%, is that 2,097,152, and the total host/net is 254. Then the class D and E are also 12.5%. So let's go now to IPv6 address representation. IPv6 addresses are 128 bits in length and written as the string of hexadecimal values. So we can say that the IPv4 a while ago is just written in the binary. Then now the IPv6 is written in the hexadecimal and has a length of 128 bits. So there are rules in the IPv6. So rule number 1. Rule number 1, omit leading zeros. Like for the first rule is to help reduce the notation of IPv4 addresses to omit the leading zeros in any 16-bit section or hex type. So, like for example, the given example is 0, 1, AB. So, it can represent as 1AB. So, we omit the leading zeros. Next one is 09F0. So, can be represented as 9F0. So, we did not omit the last 0 because it is not leading. So, we just omit the first 0. That is the 9F0. Then 0A00. we can represent as the A00. Again, we didn't omit the last two 0 because it is not leading 0. Rule number 2. Omit all 0 segments. So, these are the example. So, this is the given. 2001 colon 0 db8. db8, it's hexadecimal. Then, colon 0000. Then, colon, then 1111. Colon 000. 0000. That colon 00. Colon 0200. So we will just omit the leading zeros to have short or small segment. So we will omit all the 0 segments. So, if we compress that, so it will become 2001 colon db8 colon 0 colon 1111 colon 200. So, it becomes short if we omit all the 0 segments. So, the IPv6 address type. So, there are 3 types of the IPv6. The unicast, it is uniquely identifies an interface. Then, the multicast is used to send a single IPv6 packets to multiple destinations. Then, the anycast is any unicast can come into multiple devices. So, the unicast is uniquely identifies. Then, the multicast is it can send the single IPv6 packets to multiple destinations. Then, the anycast is from any cast addresses. Any IPv6 unicast addresses can be assigned to multiple devices. IPv6 link local unicast addresses. An IPv6 link local addresses enable a device to communicate with other device on the same link of the internet. So, to connect the IPv6 to the other enabled devices, so it needs to be in the same link. In the IPv6, they also have the static configuration of the global unicast address and dynamic configuration. EUI64 process and random generated. When the RA message is either SLAAC or LRSLAAC with stateless DHCP version 6, the client must generate its own interface ID. Dynamic link local addresses. All IPv6 devices must have the IPv6. A link local addresses must be established dynamically and configured manually as a static link local address. Ping testing connectivity to remote. So the pinging. So it used to test the ability of the local host to how to communicate across an internet network. So the ping we use this also in the packet tracer. So after we set all the IP address and the configuration to to for us to know if it is correct our configuration and everything, and if all the devices has communication or can communicate properly to the other devices. So we use the ping. So in the command prompt, we just type the ping, then the IP address of the other devices. So that's all for the chapter 7. So it's all about the IP addressing. We use the IP addressing for us to communicate proper, for the host to communicate to the other devices properly. So thank you for watching.